Hello and welcome. Today we're going to be discussing section 10.7, which is on comparing populations. In previous courses, you have learned that you use the mean and the mean absolute deviation, or what we refer to as the MAD in more simple terms, to describe symmetric distributions of data, which you will see on the next slide. However, you use the median and the interquartile range, which we abbreviate as the IQR, to describe skewed distributions of data. The first thing that we are going to discuss is an example of comparing symmetric distributions. So on the next slide, we are going to talk about the mean and the mean absolute deviation of two different data sets. In this example, the double dot plot shows the time that each candidate in a debate spent answering each of 15 questions. The blue dot plot on top shows candidate A. One of the questions he took 50 seconds to answer. For two questions, he took 60 seconds to answer. For two more questions, he took 70 seconds. Three of the questions took him 80 seconds, and so on. For candidate B, below in red, 3 questions took only 30 seconds, 1 question took 40 seconds, 2 questions took 50 seconds, and so on. These two data sets are essentially symmetric. If we draw a line right down the middle of candidate A, we see that the left and the right are almost mirror images of each other. The only thing that's out of place is a single dot here on the left. If we eliminate this dot, then the left and the right are exact mirror images of each other. So we say that candidate A's responses are essentially symmetric. Similarly, for candidate B, if we look at the middle, which is actually on exactly 60 seconds, we see that the left and the right are basically mirror images of each other. The only dot out of place is the one extra dot here on the 30 seconds. If we eliminate that dot, the left and the right are exactly the same as each other. So again, candidate B's responses are also symmetric. Because of that, as mentioned on the previous slide, we are going to use the mean and the MAD to compare each of the two data sets. The first thing we need to do is find the mean of candidate A. The mean is just another way to say average. So for candidate A, to find the mean, all we do is add up all values in the data set and divide by the number of values there are. So I am going to add whatever value this dot holds with whatever value these dots hold, with whatever values these dots hold, all of them, and then divide by the total of dots that there are. For example, this first dot was a 50-second response, so I start with 50. After that, I have two dots that are 60 seconds, so I add 60, and I add 60 again. I have two more dots at 70, so I add 70, once for each dot, and then I add 83 times. I move on to the next three, which are at 90, so I add 93 times. My next dot is 100. My next two are 110. And my last dot is 120. This might look a little intimidating, but if we just use a calculator to sum all these numbers, we can add them fairly quickly. In doing so, I obtain 1,260. Now this is not the mean, this is just the sum of the total responses for candidate A. To find the mean, after I add up all of the values of each dot, I now need to divide by the total number of dots that there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or if we count the number of numbers that I just added, there are 15 of them. So I divide this by 15, and I find that the mean is going to be 84. Or, in other words, on average, candidate A took about 84 seconds to answer each question. We now repeat this process for candidate B. The first 3 dots are all 30 seconds, so I start with 30 3 times. The next dot is 40. The next 2 are 50. The next 4 are 60. The next 2 are 70. The next one is 80. And the last 2 are 90. Then again, we simply pull out a calculator to add all these numbers. In doing so, I find that the sum of these numbers is 870. Now, to complete the process of finding the mean, I need to take the sum and divide it by the total number of numbers that I just added. If we go and count all these numbers up, we will find that there are 15. So 870 divided by 15, again we do this on a calculator, and find that the average, or the mean, is 58. Looking at the two numbers that we just got, 58 for candidate B and 84 for candidate A, we see that on average, candidate B, here in red, took much less time to answer each question. On average, candidate B only took 58 seconds to answer each question, while candidate A took 84 seconds to answer each question. Now that we have compared the mean of each candidate, we will compare the MAD for each candidate. The process of finding the MAD, or the mean absolute deviation, for each candidate is going to be somewhat lengthy. I'm going to go through the process one time completely for only one candidate, and then for candidate B, I will simply tell you what the MAD should be. When finding the MAD, what we are doing is finding the average of the distance of each dot from the average. So the first thing I'm going to do is find the distance of each dot from the average for candidate A. For candidate A, I have one dot at 50. I want to know how far is that from the average of candidate A, or the mean of candidate A, which is 84. So I'm going to take 84 and subtract 50. I get a distance of 34. That dot has a distance of 34 from the average. I then repeat that for the next dot in my data set. The next dot in my data set has a value of 60. My average is 84. I subtract 60 to find how far the 60 is from 84. I get 24. I repeat this for the next dot, which is also 60. 84, take away 60, I get 24 again. Repeating that for the fourth dot, which is 70. I have 84 take away 70, which is 14. Again, I have another 70, so 84 take away 70, I get 14. The next three dots are all 80, so 84 take away 80 gives me 4. Again, 84 take away 80 gives me 4. And lastly, 84 take away 80 gives me 4. Now I still have the right half to do. 90 is my next dot. Since 90 is bigger than 84, I'm going to start with the 90 and take away 84. We never want negative numbers. 90 take away 84 tells me that it's 6 units away. 90 take away 84 tells me that that next dot is also 6 units away. And I have a third 90, so 90 take away 84 is 6 units away. Moving on to my next dot, 100. 100 take away 84 tells me that it is 16 seconds away. 110 take away 84 gives me 26. Another 110 take away 84 gives me 26 again. And lastly, I have 120. Take away 84 giving me 36. Now that I have the distance of each dot from the average, I need to find the average of these distances. So I repeat the process that we did in part A with the values that we've just obtained. So I'm going to add up 34, 24, 24, 14, all of these numbers, and then divide by the number of values that there are. First, I will find the sum. And I will do so using a calculator. Punching all of these values in, I find that they add up to a sum of 253. To go through and find the average, I now need to divide by the number of values that I just added. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 again. So I take the 253 and divide that by 15 to find the mean absolute deviation is about 16.86, which I can round up to 16.9. So this is about 16.9, which tells us that on average, each dot in candidate A's responses are about 16.9 seconds away from the overall average of 84. Now, I did tell you that I would not walk you through the process again for candidate B. So I will just tell you that the MAD for candidate B is about 15.7. This means that on average, the responses for candidate B were about 15.7 seconds away from the overall average of his responses, which was 58 seconds. Looking at the MADs for candidate A and candidate B, we see that candidate B's were slightly smaller. This means that overall, his answers were a little bit closer together. On average, they were only 15.7 seconds away from the center, which was 58, while candidate A's answers were on average 16.9 seconds away from the center, which was 84. We can say that candidate A's responses were more spread out, in a sense, than candidate B, because the MAD is slightly greater. Candidate B's responses, on the other hand, were slightly more similar or more close together in value because the MAD is slightly smaller. This is only to be done if your data sets are somewhat symmetrical. On the next slide, we're going to quickly discuss what to do if your data sets are not symmetrical. In example A, this double box and whisker plot shows a random sample of 10 speeding tickets issued in 2 states. Compare the samples using measures of center and variation. Can you use this to make a valid comparison about the speeding tickets in the 2 states? We are going to just very quickly discuss comparing the samples. If we look at state A, we see that there's a very, very short tail here from the smallest data point up until the beginning of the box, while on the right-hand side there's a very long tail extending from the right side of the box. State B is a little bit pushed to the right, so these are not symmetrical. Since they are not symmetrical, what we are going to compare are the medians of the two and what we call the interquartile ranges. All we are going to do is look at the center line of each box. This is the median of each data set. We can see that in the blue data set, the median is lower. The interquartile range is just the width of the box. If we look at the width of each box, we see that the pink box is much greater. This is all we have time to discuss for today. We're going to go ahead and pick up the rest of this in a future lesson. Thanks for watching, guys. Have a great rest of your day.